So I will wait a little bit for everyone to join to YouTube. Okay, so most of you are already there. So I will write something on the board. So in the meanwhile, people are joining, please think about this. So we talked a little bit about how to find the minimum of a quadratic equation, function. So do you remember? We talked about a function of this form. And I told you it's very important to differentiate the difference between a quadratic polynomial and a quadratic equation. So in a quadratic polynomial or quadratic function, I don't have equal to 0 anywhere. Of course, there are some relations between quadratic equations. For example, if you want to explore some properties of this function, you can somehow use the quadratic equation as well. But in principle, they are two different things. Yes, one of them is a function, the other one is an equation. For example, I cannot ask you what is the graph of an equation. I cannot ask you, but I can ask you what is the graph of a function. I cannot ask you solve a function. This is meaningless. I can ask you solve a quadratic equation. So these are different differences that you need to appreciate. So how many of you are here? There are also 19 here. So should we wait more? So let me write something on the board. So as I start with this example, this is not something new. We learned everything from yesterday. So example, determine the minimum of y if y is equal to this expression, x squared. I will give you a simple example to refresh your memory. X squared plus 10x plus 30. Okay, if you remember the lesson from yesterday, we talked a little bit about the graph of these functions, and I told you that they are more or less of two types, and they are called parabolas, yes? So the graph of such a function is called a parabola. And then I told you that mainly we have two categories of parabolas in your lesson for a quadratic function. Either they open up or they open down. Yes? This happens, of course, I haven't motivated exactly. I just gave you a simple example for x squared and negative x squared. Then using GeoGebra, I showed that the graph of one of them is something like this. The graph of the other one is something like that. Then I told you that this feature, the reason that this is behaving like that is because of the negative sign for the a number here. So of course I haven't fully argued for that, but it will come later. Okay, so if a is positive, then you need to know these properties for this function. They are not given in the formula sheet. So these are some information that you need to know for this function. If a is greater than 0, then the parabola opens up, and if the a is less than 0, parabola opens down. So if you remember this from the previous session, which I just presented in a hand-wavy way, so you realize that this is a correct sentence. For this function, I cannot ask you what is the maximum, but I can ask you what is the minimum. Okay. Now, do you have any idea how to do this?
We do completing the square method.
Yes, so that is the method. That is very good. So what I do, I start doing this, completing a square. Of course, this has 3 terms, but only one of them is a complete square. So it seems that this is not still it's not still a squaring pattern in its own. So I need to have some remedies. I need to amend a little bit, to change a little bit here so that it becomes a quadratic pattern. But of course, I cannot just change the problem. I need to still talk about the same y. Okay? So this means that I want to keep the left-hand side the same, but I want to change the form of this function in a form that at least a squaring pattern appears there. Okay? So do you have any idea what to do? It's not that hard. You need to concentrate here. For having a square pattern, this term is good. I want to have a complete square. This term might be good, but it needs a number that matches with this number. Do you remember how did I find my magic number when we were doing quadratic equations from squaring, from completing the square? I told you a trick. You can divide this number by 2 and then raise it to power 2. So your magic number is actually 25. Yes? But unfortunately, instead of 25, I have 30. Why this is 25? I divide 10 by 2, it becomes 5. 5 to the power of 2 is 25. The number that I need to make the first 2 terms combined with that number to make a complete square is 25, but I have 30. But so you need to do it like this. You need to write 25. Don't worry about that for the time being. And then you have to make necessary changes so that you go back to your 30. Because if I don't do that, I just write 25. Of course, this is nonsense because I am saying that 30 is equal to 25. When I write equality, I need to respect the meaning of equality. Okay, so I write 25 and I ask myself, how can I fix it? How can I fix it? It's clear. I want to have 30, but I have written 25. So to make it 30, I need to add 1 5 to it. Now everyone agrees that this equality is sound, yes? But what is the benefit of that? I'm just telling you, be careful. There are infinitely many ways to write 30. I can write 29 plus 1. I can write 28 plus 2. I can write 35 minus 5. Why on earth I have chosen this combination? Because I have a goal. The goal is to make this number in a way that I make a complete square out of it. So this is my recommendation. You first ask yourself what that number is that makes the complete square. And the trick is divide this number by 2 and a square. Write that number here and ask yourself, how can I go back to the original number in the problem? That is the only simple question that you need to ask yourself. Here, in my case, the number is 25, but the number given here was 30, so I need to add 5 to it to go back to 30. If it was 35 from the beginning, I have to write 25, and then I had to add 10 to it. I don't know, if it was 20, still I have to write 25, but this time I have to subtract 5 from it. Anyway, I have to go back to my original number. That is the very simple idea. It's very simple. Why this is useful? This is important to understand. Why this method is going to work? This becomes equal to, the first 3 terms becomes a complete square, so then you have enough experience to write it. It becomes x plus 5 to the 2. If you don't understand, please interrupt me. And then you have a 5 at the end. Now, if I ask you, what is the minimum value of this, everything is clear. I want you to understand this point. Why it was not clear here? The reason is that if I only stick to positive numbers, of course it is clear when I put positive numbers and I increase them, the value of this is going up. But when I put negative numbers instead of x and I calculate this, the behavior is more complicated. Because when I put negative values, this one is not affected because of power of 2, that minus sign becomes positive. So still this part goes up. This part, if I put negative numbers, go down. And this is a constant. So it is not a priori clear which one will dominate here. So you see, it is not easy to answer the minimum here by looking at the values of the functions, because there are infinitely many possibilities for x. And I don't know. For positive x, of course, it is clear. When I increase the value of x in the positive part, it is always going up and up. And so it means it is useless because I am interested in the minimum. But if I go to negative values, it is not easy to predict. Because, for example, if x is a very small negative number, okay, and then this will dominate, so it becomes somehow positive. But if I increase the negative value of x very much, then this becomes positive. So the behavior of being positive, negative, depends highly to the behavior of the function and the values that I want to put in. So this is my advice. I want you to understand why we have to do this, because it is not clear which value makes this one minimum by looking in this form of the function. But what I have written here is exactly the same function. Why? Because you see equality, you see equality. So these two things are the same. So if I minimize this, it means that I am minimizing this because they are the same thing. But minimizing this is easy for me because I do not have a mixture of behaviors. You see, this part, if I ask you, what do you think about possible values of this part? Of course, there are still infinitely many possibilities that you can put for x, but forget about this 5 for the time being. If I ask you what is the minimum value of this expression, can you answer this question immediately and without any doubts? What is the minimum of this expression?
0.
Yes.
X is minus 5.
Exactly. Very good answer, Benjamin. Thank you. That is the most complete answer. The minimum of this part is definitely 0. How should I know that? I don't need that much knowledge because I don't care what I put here. This is power 2. So it is always non-negative. So it is greater than or equal to 0. But can I achieve the value 0 here? The answer is again yes. It is clear that if I make this one equal to 0, meaning that if I choose x equal to minus 5, the value of this blue part becomes 0. So 0 is one of the values for this on the one hand. On the other hand, this expression for any other values is greater than 0 because of power of 2. So by this reasoning, by this argument, I realize that this part is a non-negative number. So this part is a non-negative number. So what does it mean? It means that this is greater than or equal to 0. Now, I have a number which is greater than or equal to 0. It means that the minimum of only this part is 0. But now I have 5 more. I'm adding 5 to it. So it means that to any value of this, I am adding 5 on top of that. So the minimum value becomes how much? How much? 5, exactly. So this means that this is greater than or equal to 5. Is understandable for everyone. This is a non-negative number. I am adding to 5. So definitely this expression is greater than 5. Be careful. Can I say that x plus 5 is greater than or equal to 5? Is this guaranteed? Why? Why it is not guaranteed?
Because x can be any number that's negative.
Exactly. For example, if I choose x equal to -1, then this is not greater than. So this is not guaranteed. When this is true, move 5 to the right. It tells you that if x is positive, this is guaranteed. But if I don't know if x is positive or no, I cannot guarantee that. But what do you think about this situation? Can I say this is guaranteed?
Yes.
Yes, because even though here x can be negative again, but because of this power 2, this is guaranteed that this part is a non-negative number, even though x itself might be a negative number. And then I am adding a non-negative number to 5. Definitely this is guaranteed, but this is not guaranteed, yes? This is only true if x is greater than or equal to 0. But this is true for every value of x. This is more or less the same thing, only I have a 5 here. So now if I ask you what is the answer to this question, so you would say that minimum of y is equal to 5. I hope that every one of you understands what's going on. So y is equal to this. I was able to write it in a different way so that arguing about the values of y becomes easier for me. And then from this argument that this is non-negative, I realize that this is greater than or equal to 5. So look, y is equal all the way around up to this point, and then greater than or equal to 5. So it means that y is always greater than or equal to 5. So if I ask you what is the minimum, you would say the minimum is 5. Minimum of y is 5. But when this minimum is achieved, so it means that I am asking you this question. I have a bag. I start putting numbers, whatever you like. I have to put all the numbers. Practically not possible because I have infinitely many situations. But you can imagine that. Assume that you are putting all these numbers and you have a very good calculator. You calculate all of them. You get a bunch of numbers here, infinitely many numbers. One of these numbers is equal to 5. Do you agree? Why one of these numbers is equal to 5? Because if I put -5 here, -5 to power 2, 25, plus 30 is 55, minus 50 is 5. So when I was doing this, when it comes to the turn of -5, when I put it here, it produces me 5. But there are infinitely many other numbers. By this argument, I am telling you that don't waste the time. If your goal is to find the minimum value in this bag, that is 5. And that is understandable here. And you might ask when 5 is achieved. When I get to 5. Can you answer that? It's clear. I want to make this equal to 5. My minimum is 5. How can I make this one equal to 5? I can make this one equal to 5 if I make this part equal to 0. Because if this is not 0, it is positive. When I add it to 5, it becomes greater than 5. I want to make this one equal to 5. I have only one option. I have to make this blue part equal to 0. What value I should choose for making this equal to 0? Hopefully everyone see that if I choose x equal to -5, I will reach this 5. So minimum of y is 5. This minimum, it is not part of this question, but this is also good to know. This minimum is achieved or is attained if x is -5. Both of them are important to understand. What is the minimum possible value? the answer is 5. When I can reach to this minimum, you say me, okay, it is enough to choose the value for x equal to -5. It will give you the minimum value there. But if you choose any other number except -5, then you will get a lot of numbers. All of them are greater than 5. So I want you to appreciate this method. There are infinitely, even if you have a supercomputer, because there are infinitely many possibilities. Even for the supercomputer, it needs infinitely many years to accomplish this problem. This problem cannot, by the way, accomplished. Infinity cannot be accomplished, yes? But mathematics tells you that don't worry. If your goal is the minimum value, we got it. We don't even need to bother a lot. Just under 1 minute, we can solve the problem. So this is the core idea of finding the minimum. Is that understandable for everyone?
Yeah.
The problem becomes a little technical if I want to talk about a maximum. Not because of the nature of the problem, because of if you have a little bit of weakness in your algebra. So now let us talk about a maximum situation. Of course, if you trust me on what I told you, you know that I have to start with a situation in which this number is negative, yes? So let us talk about that. Let me make it very simple first. Example, before continuing, let me tell you one thing. It is in the book as well. So you see that if you draw the graph of this using GeoGebra, you will get something similar to this graph. Which place, we don't care. Somewhere you see this graph. And then this point, we have two names for this point in your book. One of them is called the turning point. I'm writing a little bit small, hopefully you see. The turning point. Okay, what does it mean? It means that function is going down here. When it reaches here, it turns back and goes up. So it is turning for this. Or people call it local minimum. Or minimum, okay? Local minimum or minimum. The minimum here, let me put it in brackets. So this would be the topic of next year, okay? So this is the minimum point. Minimum point. Or you can call it turning point. Turning point, so let me write these things for you. So if we have a graph like this happens if I have, for example, this situation. I will clean it later. I want to make it a little bit big so that you can see it easily. If I have my parabola like this, it happens when A is positive. And this lowest point is, there are three names for that, okay? The good name is the minimum point. This is a very good, this is the best probably name for it, because the turning point, this one is a maximum, but this is also a turning point, yes? Because it goes up and then suddenly turns down back. So that's also a turning point, yes? So turning point has two, so let me, this is the minimum point, it would be better, but you can also call it the turning point. Or sometimes you can call it an extreme point. Or the extreme point, yes? Because for this function, there is only one. The extreme point. All of them, you need to be familiar with these words. But this is a better one for this situation because you understand the meaning. If I say the turning point or the extreme point, it is not clear. I understand that there is something turning in that point, but I don't know, is it this one turning or is it this one turning? If I want to mention this one, I would say a maximum point. That is better. But still, so what I'm saying is that when people talk about extreme point and turning point, it is not clear, are they talking about maximum or minimum? Both of them can be categorized under the name of turning point and extreme point. But if you want to be more explicit, it's better to call them the minimum point if it is a minimum, and the maximum point if it is a maximum. I do not write something. There is something similar for this. For the case where A is negative, I have the other way around, okay? I want to clean this one now. And now we want to talk a little bit about the situation in which that I might have a maximum. And then probably you need to know that I have to start with a quadratic equation for which the quadratic term is negative, okay? So let me start with this example. Okay, so example, determine the maximum of y, or you can say the maximum value, it doesn't matter, the maximum of y if y is equal to minus x squared plus 2x. That is also a quadratic function, and you see that I have respected the rule to put a negative sign here. I haven't convinced you right now why, if this is negative, there is a maximum, and when this is positive. I just draw an analogy by doing some graph things, okay? We can come back to this later. Okay, so let us see what happens that I cannot ask about minimum in this case. I have to ask about maximum. By the way, let us go back and look. Can I ask what is the maximum of y? Of course, I can ask, but what is the answer? Look here. You see this function is equal to this function. I realize that this is greater than or equal to 5, so it means that the lowest possible value, the minimum, is 5. But if I ask you what is the maximum value for this function, what do you answer?
There is no answer.
Exactly. Why? Because it doesn't matter. I can always increase x, increase it and increase it. By increasing x, this value goes higher and higher. Yes, it becomes bigger and bigger. So there is no upper bound for the values that I can go up to there. Yes. If I have 1 million, for example, I can make x bigger, then it goes above 1 million. If I go to 1 billion, if I make x bigger, it goes above 1 billion. So there is no upper limit for the values for this function, the values that this function can attain. But there is a minimum value that this function can attain. Okay, now let us see what is the situation here. Assume that you don't know there is a maximum or minimum. Let us see how can I understand the behavior of this function. The idea is, again, the completing a square. But there is a technical thing going on. I don't know. If you are good in algebra, you know how to deal with that. But otherwise, I can help you. So do you see the idea? The idea is, again, the completing a square. In this situation, at least I saw one complete square. X squared was complete square. In this situation, is minus x squared a complete square?
Yes.
No. The answer, why it is not a complete square? Because of this negative sign. If you have a negative number, that negative number cannot be a complete square. So that is the obstacle. So you need to understand, what can I do with this negative sign? I cannot just drop it. If I want to get rid of this negative sign, one way of thinking about this is to multiply this num y by a negative sign. But then, whatever I talk about is about minus y, not about y. That is also possible. I will come back to it. Okay, so before doing that, so this is why I don't want to multiply both sides by minus sign. One way to get rid of this minus sign, I cannot just drop this minus sign. This is equality. If I want to get rid of this minus sign, one way is to multiply both sides by negative sign. This becomes negative y, and this becomes x squared. Good. But the problem is that after that, what I am talking about negative y. I'm not talking about y, but I want to answer the question for y, not for negative y. Okay? So I will teach you how to do it if you want to multiply by negative. But before doing that, let us follow the book. What can I do here? Do you have any idea? First of all, I don't want to have this negative sign here on the one hand. On the other hand, I have the negative sign there. I cannot just simply cross it over. I need to find a wise way to deal with it.
Can't you just rewrite it as -1 times x to the power of 2?
Okay, but then again, -1 is minus. What can I do about -1? -1, that's right, because minus x squared, what you are saying is -1 times x squared. Okay, still, even though this is true, but still it is not a complete square because of this -1. So that will not solve my problem.
Can't you take out the negative sign and then put x to the power of 2 minus 2x?
Exactly. That is the trick. I told you, whenever you have the wrong sign, it's always better to think about this technique that you can pull a negative sign out. Do you remember? I talked about this before. If you have a minus b, but I don't know, you need b minus a, one possible trick is to put a minus sign behind a pair of brackets and write b minus a. More or less the same idea is true here. So I will start with y. My y is, let me write it in one row here. So this is the y that I want to talk about. But because of this problem of minus sign, I want to get rid of that. So I pull a minus sign out. But then I have to pay a price for that. This positive 2x becomes negative 2x. But that is not a big deal. No problem. But at least this is now a complete square. But the problem is that I have only two terms. I have to make it a complete square. Momentarily, you can totally forget about what is happening outside the pair of brackets. Just follow what you learned for the minimum case. Meaning that you write this equality, you copy and paste the negative sign, you open a pair of brackets here, and then try to use the technique that you learned here. What do you need for making this a complete square? So x squared is there, minus 2x is there, but you need some other number to make the whole combination a complete square. What that number is? 1. The trick is to divide this, exactly. To divide this by 2, it becomes a -1, and then square it, it becomes positive 1. But am I allowed to just blindly put a positive 1 there?
No.
What should I do?
-1 after that.
Exactly. So I have to put a -1 as well. Because if I don't put this -1, I am not allowed to use this equality. Equality means equality. So I cannot write something bigger here and say that they are equal. Unless I do this to compensate for this one added. And then, you see, I am just momentarily ignoring this negative sign. But I now know that these three are complete squares, so it becomes x minus 1 to the 2, and then I have a -1 here. Okay? So you see, you pull out a negative sign, and then what you learned for the minimum case, momentarily you forget about what's happening outside the bracket, just copy and paste, and then you learn the trick for the minimum, just do the trick, and you get this one. And then at the end, multiply this negative sign back into the whole pair of brackets. So what happens? This minus sign will go for this one and that one. This is the new part. So this becomes minus x minus 1 to power 2, and minus times minus is positive 1. And I myself, as I told you, I'm optimistic. I will always start with the positive sign. and this becomes x minus 1 to the power of 2. Okay, so what I have started with is exactly equal to this expression. Okay, now you understand why this negative sign is so important, and it changes the behavior of my function. Because, can I ask you, what is the minimum value of this? So be careful here. You have a constant minus something else. You do not have a constant plus something else. This, what is inside this box is non-negative. Do you agree with me? This is x minus 1 to power of 2.
Yes.
So exactly, this is a non-negative number. But this time, I am not adding a non-negative number to 1. I am subtracting a non-negative number from 1. So, which one is correct? Do you think that I can write greater than or equal to 1, or I should write less than or equal to 1? Which one do you believe in? Less than equal, completely clear. So because I have a constant, I am taking positive values out of it. So I am making it a smaller and a smaller. So 1 minus this expression, this is not correct. I cannot conclude this, but I can safely conclude this. So what happens? It means that this y that I am interested in is less than or equal to 1. If I know about this, can I answer the minimum or can I answer the maximum? Maximum. And what is the maximum? Is 1, because you are saying to me that y is less than or at most equal to 1. So this means that the maximum is equal to 1. So you see, the reason is because of this minus sign. If you start with the positive value here, what you get at the end is a number. This number can be positive or negative. Forget about that sign. But the crucial point is that the sign behind this becomes positive. So you are adding a positive number to a constant value, so that expression becomes greater than or equal to that constant value. But if you have this negative sign, so you see, keep track of this negative sign. It's playing a crucial role here. And at the end, this negative sign appears here as a negative sign. So in this case, I cannot talk about minimum value. I can talk about maximum value. There is no minimum. Why? Because I can increase x make it very big, then to power 2 it becomes huge, and I am writing 1 minus that huge number. It's a huge negative number. And I can make it even more negative by increasing the value of x. Yes? So this means that there is no lower bound for the values of y, but there is an upper bound that can be achieved. The upper bound is equal to 1, and it can be achieved. Can you tell me for what value of x I will get 1 in my bag?
0?
No, be careful. Be careful. It's a 1. Because I want to make it equal to 1, it means that I have to make this equal to 0. When this expression becomes 0, this expression becomes 0 when x is equal to 1. So the maximum, if I want to write it like before, first of all, you understand. So let me complete it here. No maximum. But here, I would write that maximum. It doesn't matter if you write capital letter. There is no, it doesn't, not important. Instead of writing English, I'm just writing, I'm a little bit lazy in writing. Okay, maximum of y is equal to 1. No minimum. And when this maximum is achieved, this maximum is achieved or is attained when x is equal to 1. So is that understandable? So this is the core of what we know. So you see that I started with a positive x squared sign, and I ended up with a complete square with a positive sign behind that. And then, of course, it becomes greater than or equal to this constant. So it means that I have a minimum. But when I started with a negative sign, this negative sign has a crucial effect here. You see, finally, this negative sign was the one which appeared here. And then I have 1 minus a positive number. So it means that I can talk about the maximum value because I am subtracting a positive number from a constant number. So this is why I hope that you understand, even in the general case, that is the same story. Yes, in the general case, I have this situation for positive x squared and this situation for negative squared. Of course, this is just two examples, one for negative, one for positive. But when you know algebra, you can do it algebraically using letters. Of course, it would be complicated, but then you can make sure what is going to happen, not for these special cases, for the most general case. Okay? Is there a question here? Okay, let me ask you something. Can you tell me what is the turning point of this function? So let me write it here. Turning point.
Like value of 5.
So turning point means point. When I talk about a point, I mean x coordinate together with the y coordinate in an ordered pair. Differentiate these things. You see, if I talk about minimum, I mean one number for the y values, the lowest value for y. When I say when that minimum occurs or when it is attained, when it is achieved, I am asking you about the x value corresponding to that. If I ask you what is the turning point, so you need to write yes. So the turning point, or you can say the extreme point, or you can say here in this case the minimum, if you want to be very specific, the minimum point. All of them, you have to write both of them in a point. X coordinate is -5 and the y coordinate is 5. So it means that if you draw the graph of this using GeoGebra and ask the GeoGebra to locate this point in the coordinate system for you, you can immediately see that the turning point, the minimum point, is highlighted. And if I ask you the same questions here, the turning point, the extreme point, or in this case, the maximum point, what do you answer? You have to write both of them. X coordinate is 1. Here, coincidentally, the maximum value is equal to 1. So this is the maximum point. This is the turning point. Okay? So this completing a square is very good because we are able to immediately detect the turning point if you want to. But the problem becomes a little bit more complicated. And by the way, so I hope that you learned this trick. But I can also teach you what happens. Please listen to it, but forget about this. If you understand exactly what's going on, of course you can use it. But I told you that I can also multiply it by negative sign. Okay, so let me just do it very quickly. Even though if you learn what is going on, you are done. This is not discussed in the book, but this is also one possibility here. Let me do that. Okay, let me do this. So in both of them, I have y. equals to minus x squared plus 2x. One possible way is to multiply this by negative sign. This is also mathematically valid. If this is equal to this one, if I multiply this by negative sign, that is also valid. Okay, but this is an easy one. So you keep minus y and then continue. Let me write it in this way. Minus y is equal. This one doesn't have any problem for you anymore because this becomes positive. And then you know what to do. You want to make it complete square, you need 1, but you cannot bring 1 out of your pocket, put it there, so unless you subtract it. Yes? And then what happens, you see, I am just writing minus 1, but be careful. I want to find the minimum of y. Okay? So then this part becomes x minus 1 to power 2 minus 1. Okay? As I did before. And then if you want to, you can multiply it by a negative sign at the end. If that's a little bit hard for you, that's also possible. So, but if I multiply this by a negative sign, I have to do it because I want to talk about the same value. So I multiply by a negative sign. This becomes positive 1. This becomes negative. And you see that what I have done here is what I got at the end is exactly what I did it using this method. So choose whatever you like. That is also, I would say, it's easy. This method might be actually a better way to do this. Yes, especially if you have numbers appearing here. Okay. Let me give you another example of that type, which becomes algebra more complicated, but the idea is not complicated. Okay. So let me give you another example. I think this is also a good way to do it. Might be it's a little bit easier. For example, let me follow this method for this. A little bit more complicated one. So y is equal to 2x squared plus 6x, and then I have plus 5. Which one can I ask? Can I ask find the maximum or should I ask find the minimum? Minimum, because I have started with a positive number. But I hope that you understand the big difference here. I do not have even one single square, complete square here. In the previous examples, I started with x squared, so x squared was a complete square. But here, none of them is a complete square. So the problem becomes a little bit more complicated. That's also in the book. This is not something extra. Okay, so what you do? If you want to do something like this, can you propose something to me here? So what is your problem here? Your problem here is not the minus sign. What is the problem here? Can you detect what is the reason?
There's a 2.
And there is a 2. Exactly. So how did you get rid of this negative sign? By doing something on both sides so that you can get rid of this minus sign. So the strategy can be the same again. Here, I want to get rid of 2. So what can I do? Divide by 2 both sides. Yes, so that's possible. But be careful. When you divide by 2, so I want to ask, let me write this equals minimum of what? What is minimum of y? And when it is achieved? Or write the turning point. All of these questions are the same. Not the same, but you need to follow the same process, and then at the end, the answers are slightly different. Okay, so you divide by 2, but be careful. If you continue only with the right-hand side, this becomes 3x, and this becomes 5 over 2. If you just continue with this, you are talking about y over 2. You are not talking about y. But that is a minor thing. We can change it a little bit later. Okay, so you continue with y over 2. What happens? At least I have a complete square here. This problem becomes a little bit complicated because of the fractional numbers. But don't worry about that. Can you tell me what is my magic number? What number I should add here? Because still these two are not complete squares. I have only one complete square. So let me put this here, the empty box. And of course I have a 5/2 there. So what should I put there to make it complete square?
6/4.
No, you are mistaken. Yes, your method is correct. 9/4. You need to divide this number by 2 and square it. A square means multiply it by itself, yes? So it becomes 9/4, not 6/4, yes? So the number that you have to add is 9/4. Okay, but do you agree with this equality? No, I just take it out from my pocket and put it here. To make everything right, what should I do? Tell me. Subtract, exactly. The reason that I am doing this because these fractions are not easy to guess. I don't want to make mistakes, so I am writing them patiently. I divided everything by 2. I asked what is the number that I have to add. I went to the scratch paper, I calculated that, and then I say that, okay, I am adding 9/4 to here to keep this equality meaningful. I have to take it away. Now, this minus 9/4 and that 9/4 are gone, and I am having the same thing. So what I have written here is completely legal, yes? What I have written here is exactly the same expression. But I have a goal. What is the goal? Then these 3 terms make the complete square for you. Still, be careful. You are copy and pasting y/2. And then what happens? Can you tell me what can I write here? Definitely, you know that it should be a complete square. And I think it's easy to guess. What is that one? What should I write? The square root of this one, x. The square root of this one, which is 3/2. Yes? And then positive or negative, because the middle term is positive, this is the positive version of the squaring pattern. And then, so these three terms are collected into this term. So 2 terms are involved, but this, nobody starts writing them again because I can go to scratch paper and simplify these 2 numbers. Okay, if you can do it in your head, do it. Otherwise, use your calculator or go to scratch paper. So here, instead of 5/2, I can write 10/4 to make the denominators the same. And then what happens? It becomes 1/4. So instead of writing 5/2 minus 9/4, I can simply write 1/4. Okay, now let us say that, okay, this is what I want to talk about. Do you think, forget about the name. If I ask you, is there any minimum for this or is there any maximum for this? What is your answer?
Minimum.
There is a minimum because the lowest value of something to power 2 is 0. So this part is greater than or equal to 0. And then I have 1/4 on top of that. So this means that the whole expression is greater than or equal to which number? Can you tell me? 1/4, thank you. But now, let me take this one. This is not y. y/2 is greater than or equal to 1/4. But you know from the beginning, you are not supposed to talk about y/2. You are supposed to talk about y. What you got is something for y/2, but what can I do? It's easy. I want to say something about y. What can I do? Multiply by 2. When I multiply this by 2, I will go back to my original y, greater than or equal, if I multiply this by 2, it becomes 2/4, but 2/4 has a better name, 1/2. Is this y the same y that I started with? Yes. So I am done. If I ask you, what is the question mark then? Can you tell me, please, what is the minimum of y by this calculation?
1/2.
1/2. When it is achieved, a little bit more tricky. This is achieved, this becomes equal if this becomes equal. When this becomes equal to this. Don't worry about that. This becomes equal to this when this part is 0. And when this part is 0, can you tell me?
It's -3/2.
-3/2, which was not a priori clear at all. How on earth I should know about that? I need to put -3/2 here to achieve the minimum. It was not clear at all. So I want you to appreciate that what we have done, even though we are living in a world that computers are accessible everywhere, but I mean, mathematically, you have done a great job here. Okay, so here I would say that minimum of y is equal to 1/2. And then if I ask you what is the minimum point, or I can ask you what is the turning point, or I can ask you what is the extreme point, I would prefer the minimum point because I am also characterizing the behavior of the point, minimum. It is equal to, the x coordinate is -3/2, the one that makes this one equal to 0, and the y coordinate is 1/2. So this is one way of asking what is the minimum, or sometimes I can ask what is the minimum value. They are the same. I can ask you what is the minimum point, then you have to answer me in ordered pair. The y value is the minimum value, and this value is the one that makes this one equal to 0. And then I can ask you when the minimum is achieved. Sometimes when the minimum is attained, you just answer -3/2. The minimum is attained when x is equal to -3/2. Let me just repeat. I want you to understand what is the meaning of your calculation. For this function, you are allowed to put any number that you like instead of x. There are infinitely many numbers that you can put instead of x. There are infinitely many numbers that you get as your output. Assume that the outputs are in a bag. We learned that in that bag, the minimum value that you can see is 1/2. And that minimum value is the consequence of putting -3/2. 1/2 is the output which corresponds to this intake, yes? If you put -3/2, then it will produce you 1/2, and that's the minimum value. So I would say that, okay, the important step is actually to understand the completing the square method. If there is a number behind that, you can use this trick. You divide or multiply or whatever to make it x squared. When it is x squared, it is easy to complete the square method. And the only thing that finally happens, first you calculate the minimum of this changed value. When you found it, it is finished. Then you say that, okay, I want to go back to my original y, and you need to see what you have to do to go back to the original y. End of the story, okay? So let me also now give you a problem that starts with a negative value. So let me make the numbers a little bit more nasty so that you get used to that. There is no big problem. The only reason that makes the calculation a little bit tedious because I am dealing with fractions, and that's normal. Okay? So here, let me write another one. If you don't mind, let me start from here. So y equals to, let us minus 3x squared plus 6x, and then let me write, for example, let me write negative. So let me make it negative, by the way. This one negative, and then let me make it minus 7. So this is probably the worst possible case. We can make one of them positive. I don't know, you can play around, it doesn't matter. Okay, so minus 3x squared minus 6x plus 7. Okay, let me start doing it together again. What time is it? We have a little bit of time, we can finalize this. So that would be the end of this lesson. Okay, so let me clean these. What we have to do? Again, what is your hunch about this? Is there a maximum or a minimum? Which one I can ask you? Maximum. If tell me, if I make a mistake in the exam or intentionally, if I ask you what is the minimum of y, what is your answer? There does not exist, exactly. So if I accidentally ask you this, that would be very good for you. You can say that the answer, there is nothing. Okay? Okay, now let us do that. Tell me, what is the first step? Let us write everything here. What is the first step? Is it hard? No, might be you are confused. Don't worry about
First
the
divide by 3, maybe?
No, not 3. Why 3? Because if you divide by 3, then you will have minus x squared. Minus 3 is better. Yes, why we should do it in 2 steps? I just divide by minus 3. So it becomes y divided by minus 3. Then I will tell you what is the importance here. Y divided by minus 3. So what happens for this is x squared. What happens for this is positive 2x. What happens to this? Unfortunately, I have to deal with fractions. Okay, but this is very simple now. So it becomes y minus 3. I have to repeat this. And then what is the golden number that I need to add to make this 2 complete a square? Very simple. What's the number? 1. I add 1. I also have to subtract it. And then I also have a negative 7 over 3. So what I have done is completely legitimate. Why? Because 1 minus 1 is just nothing. And then I have minus 7, 3, which is correct. But what is the benefit of that? Because now I can write this. These 3 terms can be collected into a complete square. So this becomes x plus 1 to the power of 2. But then you don't need to take this with you all the time. You go to scratch paper, be careful, both of them are negative. So negative 1, negative 7 over 3. You have to keep it precise. Here, 7 over 3, you cannot write it with decimal points, not at all. You have to keep the precise value, the exact value. So what happens? It becomes minus 3 over 3 to take the common denominator. So this becomes minus 10 over 3. So I would write minus 10 over 3. Okay, now momentarily forget about this. Forget about this. Do you think I can write here greater than or equal to what? Can you tell me?
Minus 10 over 3.
Exactly, because this one is non-negative. A non-negative number is added to this. So definitely it becomes bigger, greater than or equal to this one. Now let me show this back to you. This is y over 3. So let me bring this information down. Y minus 3 is equal to this expression, and this expression is greater than or equal to this number. So this means that y divided by minus 3 is greater than or equal to that number. Yes? But this information, even though correct, it is not my answer to the problem because I want to talk about y. What I got is the value for some limit, some bound for y over minus 3. I want to go and talk something about y. So can you tell me what should I do now to get information about y, not y over minus 3?
Multiply by minus 3.
Okay. Do you think something I have to be careful? So let me write it up. Should I be careful about something? You are right. I have to multiply by minus 3.
Think about the minus sign.
Okay, so what do you mean exactly? So you are right. I want to multiply both sides by minus 3 because I want to have my y alone on the left hand side. So it is clear that I have to multiply by negative 3. When I multiply the negative 3, let me write something and I ask you, do you agree with me or not? I multiply both sides by negative 3. Negative 3 and the negative 3 are gone. Okay? And then when I multiply this by negative 3, if you want, I can do it in a scratch paper. This 3 and that negative 3 cancel. It becomes minus 1. Minus 1 times minus 10 it becomes positive 10. Do you agree with this calculation? Do you see something strange? No. If I give you this, forget about all the things that I have written on board. I give you this. If you see this, can you talk about the minimum of y or can you talk about the maximum of y by just looking at this?
I think that's minimum.
That's minimum. Yes, you are right. If you see this on the board, it is telling you something about the minimum value of y. It's telling you that y is greater than or at least equal to 10. So that's talking about the minimum. But so there is something going wrong, yes, because this is supposed to have a maximum. What do you think is problematic in this calculation? Exactly. So do you remember Math 1C? When I multiply both sides of an inequality by a negative number, this is crucial that you can do this, but you have to remember, you have to change the direction of that inequality. So that is the crucial point that you need to remember when you are dealing with negative numbers. So I started making it positive x squared, which is the simplest possible scenario. And then I talked about what I get here. After that, I want to go back to my original value, but I need to be careful. When I am multiplying, dividing by negative number, and inequality by negative number, I have to be careful that I have to interchange the direction of the sign. Now, if I ask you, by looking at this, can you tell me about the maximum of y or the minimum of y? What is your answer?
Maximum.
This is maximum, and that is correct. It squares with our previous knowledge. Whenever this is negative, we can talk about the maximum. There is no lower bound. You see, we didn't detect any lower bound for y, but we detect an upper bound for y. So that's the maximum value. So I would say the maximum of y is equal to 10. Okay, can you tell me what is the maximum point? So let me write it here if you want to see the board. So the maximum point is a point with x and y coordinates. The y coordinate is exactly the maximum value. But what is, when it is achieved, when it is attained?
X coordinate minus 1.
Exactly. Why? Because you go back to this square part, you want to make it minimum or maximum. So this, you want to make it minimum, so x should be equal to minus 1. So the turning point is minus 1 and 10. Okay? So that is the end of the lesson today. Next time, this is not part of your lesson, but I want you to see it. It is not above your abilities, I would say. What I want to do next time, I want to talk about a general quadratic polynomial ax squared plus bx plus c and try to work this out so that once for all we can get a formula. Of course, this formula is not in the formula sheet, but I don't know, if you have it in your memory or whatever, you can use it after seeing the proof. The reason that this is not in the formula sheet, because they want you to do these steps so that every time you repeat it and learn it. Okay, so next time I will do this on the Friday. Again on Friday, because in the morning I am here, so I will stream it on live on YouTube because I don't have enough time to go back home. And that's a little bit unfortunate because at home, at this lesson, it was very good that if I have access to GeoGebra and the lesson simultaneously. Anyway, so next time we will deal with the most general case, and we also want to talk about one more notion, and that is the line of symmetry. Okay, of course, the line of symmetry is a vertical line that passes through the turning point. So that's as simple as that, but we will talk about this. Okay, so if you don't mind, let me just end this streaming. I go to Zoom if you have any questions. Otherwise, you can leave. Thank you for being with me.